In this video, we're going to be identifying geometric transformations. A transformation is a rule that assigns each point in the plane, or each point in a geometric figure, to another point in the plane. All right, it could be the same point. We will be studying geometric transformations on the coordinate plane. All right, all of our work is going to be done on the coordinate plane for our geometric transformations. And we've had experience with the coordinate plane in the past. So there's the x-axis, which one runs horizontally. There's the y-axis, which runs vertically. They intersect at the origin, whose coordinates is 0, 0. And that divides the graph into 4 different quadrants. All right, so if we take a look at this example down here, there is your y-axis, there's your x-axis. They meet at the origin point right there. And then we have the quadrant number 1 in the top left, or top right, excuse me. We have quadrant number 2 in the top left. Quadrant number 3 is in the bottom left, and quadrant number 4 is in the bottom right. Okay, so this is kind of an example of what we're going to be looking at in this topic with our transformations. Now, the original geometric object that we start with is known as the preimage. All right, the original object we call the preimage. After we do a transformation of the preimage, we will get different images of the preimage. What we're going to do is use prime notation to represent our image. All right, prime notation, which is kind of like this little apostrophe here, is used to represent the image after a transformation. Double prime notation, so 2 apostrophes there, represents the image after 2 transformations. And in this example down here, triangle ABC is the preimage. So that would be this triangle here, ABC. Okay, the vertices are labeled with letters without any prime notation, so that is the preimage. Triangle A prime, B prime, C prime represents the image of triangle ABC after the first transformation. We find triangle A prime, B prime, C prime right here. Okay, so this was the preimage, the original triangle. We did some transformation and it created this triangle, A prime, B prime, C prime. And then triangle A double prime, B double prime, C double prime represents the image of triangle ABC after 2 transformations. And that gets you to this triangle right here, A double prime, B double prime, C double prime. Okay, so again, when we take an image of a preimage, we're going to use prime notation to represent the images. Now, there are 4 types of transformations that we will be studying in this topic. One of them is called a translation. A translation is also known as a slide. All right, this is going to move the shape in a set distance and in a set direction. We also are going to work with rotations. Rotations are also known as turns. And in 8th grade, all right, we're going to be turning our shapes either clockwise or counterclockwise. When we rotate shapes we will rotate shapes only in increments of 90 degrees. A 90-degree rotation is called a quarter turn. A 180-degree rotation is a half turn, and a 270-degree rotation is a three-quarter turn. Another type of transformation we'll work with is a reflection. A reflection is also known as a flip. This will create a mirror image of the preimage. And then finally, we're going to work with dilations. Dilations can either be a shrink, meaning that the preimage will get smaller when we have the image, or it will be an enlargement, meaning that the preimage will get larger with its image. A shrink or an enlargement of a shape by a given scale factor. Those are the 4 types of transformations that we'll work with in this topic. We're going to study each of our different transformations in detail later in the topic. But today, all we're going to be able, or all that I want you to be able to do is just to identify the type of transformation that you see in the picture. So in our first example, we have triangle ABC that was graphed. Okay, and looking at this graph, I've got my y-axis here, my x-axis here. So I'm in quadrant number 1. And in quadrant number 1, all of the coordinates are positive. Letter A says state the coordinates of the preimage. Remember that the preimage is the original object, which in this example is triangle ABC. So we're going to state the coordinates of each point. Point A, all right, well, you would move 2 units in to the right from the origin, and then you would go up 9 units, so it's at the point 2 comma 9. Point B from the origin, you would have to move to the right 4, and then you would have to move up 13 units, so it's at 4 comma 13. And then point C, you would have to move in 8 units to the right from the origin, and then you would move up 8 units, so it's at 8 comma 8. Those are the coordinates of the pre-image. What we're going to do is state the coordinates and graph triangle A prime, B prime, C prime. This triangle is going to be the image of triangle ABC after the following transformation rule. Okay, and here's what our rule tells us to do. We're going to take each point from our pre-image, x comma y, and for each x coordinate, we're going to add 6, and for each y coordinate, we're going to subtract 8. These will give us the new coordinates of triangle A prime, B prime, C prime. Once we have those coordinates, we're going to graph that triangle on the same graph. So let's look for point A prime. All right, point A prime. What we're going to do is take the coordinates of point A, and then we're going to add 6 to the x, subtract 8 from the y. So the x coordinate of point A was 2. We're going to add 6 to that. Then we're going to take the y coordinate of A, which was 9, and we're going to subtract 8 from that. Well, that's going to give us a point of 2 plus 6 is 8, comma 9 minus 8 is 1. Point A prime is going to be at 8, comma 1. So here's the origin. We're going to go to the right 8 units and then up 1 unit. That point right there is A prime. Then we're going to do the same thing for point B prime. All right, so we're going to take B's x, which was 4. We're going to add 6 to it. We're going to take B's y coordinate, 13, and subtract 8 from it. This is going to give us a coordinate of 10, comma 5. 10, comma 5. So from the origin, we're going to go right 10, up 5 units. Right there is the point B prime. All right, and now we need the point C prime. All right, C prime was at 8, comma, or C rather was at 8, comma 8. So to get C prime, we're going to do 8 plus 6, and then we're going to do 8 minus 8. And that's going to give us a coordinate. 8 plus 6 is 14. 8 minus 8 is 0. 14 comma 0 is where C prime is located. So all we're going to do is go to the right 14 units, and we're going to stop right there because we don't have to move up at all since the y value was 0. There's C prime. Let's go ahead and use a ruler now to connect our points. Okay, so I'm going to connect A prime, B prime, and C prime. All right, so there's my first line. And now use my ruler and get my next line. Always use a straight edge when you're doing this on paper. And now get my third line, B prime and C prime. And there is our picture. There's triangle A prime, B prime, C prime. All right, and question C asks, which type of transformation does this represent? So all we did, we took triangle ABC and we slid it down over here. And actually, if we follow the rule here, we added 6 to the y coordinate, which means we actually took these coordinates and moved right 6 units. And then the y coordinate, we subtracted 8, so we moved down 8 units. So we slid to the right 6 units and then slid down 8 units. And that got us to this triangle, A prime, B prime, C prime. A slide is a translation. All right, so what we have here is a translation. Now, question D. Shapes that are congruent are identical to each other, meaning that they have the same shape and are the same. I should make that the same shape. Squeeze that in there. They're the same shape and they are the same size. Congruent means identical, which means the same shape and the same size. Are our two triangles congruent to each other? Well, looking at them, we can see that those two triangles are congruent to each other. All right, now underneath in the box, some transformations result in images that are congruent to their pre-images, and some do not. If a transformation results in a congruent image, so it's identical, then it's known as a rigid motion. A rigid motion, all right? In this example, is a translation a rigid motion? Well, if we look at our triangles, our pre-image was congruent to its image, and therefore it created a congruent shape. So yes, a translation is a rigid motion, and it is a rigid motion because the pre-image, the pre-image is congruent to the image. If the pre-image and image are congruent to each other, then that transformation that resulted in the image is called a rigid motion. A translation is a rigid motion. Let's see if we can identify another transformation. Example 2, we have square ABCD on our graph. Let's state the coordinates of the pre-image ABCD. Point A is found right here, which is at the point -3, 3. Point B is found right here, which is at point 3, 3. Point C is right here, so from the origin, 3, -3. And point D, all right, from the origin, -3, -3. Those are the coordinates of the pre-image. What we're going to do in part B is state the coordinates in graph square A prime, B prime, C prime, D prime, which is going to be the image of square ABCD after the following transformation rule. So what we're going to do is take the coordinates xy of ABCD and we're going to double them. So we're going to do 2 times x and 2 times y. That'll give us square A prime, B prime, C prime, D prime. Let's start with point A. All right, we're going to take A's coordinates, which was -3, 3, and we're going to double both of them. So we're going to do 2 times -3, 2 times 3, which means that point A prime is going to be at -6, 6. Let's go ahead and graph that. 6 units to the left and 6 units up right there. That point is A prime. B prime, we're going to take the coordinates of B and we're going to double them. 2 times 3 is 6, 2 times 3 is 6. B prime is at 6, 6. So from the origin, 6 units right and then 6 units up. Right there is point B prime. C prime, we're going to take the coordinates of point C and double them. 2 times 3 is 6. 2 times -3 is -6. 6, -6 is C prime. So from the origin, 6 units right and 6 units down. That is point C prime. And then we need point D prime. Double D's coordinates here. -3 times 2 is -6. -3 times 2 is -6. -6, -6 is point D prime. From the origin, 6 units left and 6 units down. Right here is point D prime. And now use your ruler to connect them. Okay, so we're going to create square A prime, B prime, C prime, D prime by connecting our 4 points. So give me one moment to do that quickly here. And then this will be the image of square ABCD. All right, there is our picture now. All right, A prime, B prime, C prime, D prime. Which type of transformation does this represent? Okay, well, our image is bigger than our pre-image. So we can say that our pre-image, we enlarged it to make the image. An enlargement is an example of a dilation. Okay, this is an example of a dilation. Is this a rigid motion? Is a dilation a rigid motion? Well, remember, a dilation is not going to be a rigid motion because rigid motions have to create shapes that are congruent to each other. And looking at this, the pre-image ABCD is not congruent to A prime, B prime, C prime, D prime. They are the same shape, they're both squares, but they are not the same size. So is this an example of a rigid motion? No. A dilation is not a rigid motion. A dilation is not a rigid motion because the preimage is not congruent to the image. If the preimage and image are not congruent to each other, then that transformation is not a rigid motion. A dilation is not a rigid motion. Remember that dilations are enlargements or reductions, all right? We would shrink them if it's a reduction, so they're not going to create shapes that are the same size. So a dilation is not a rigid motion. In our next example, we have triangle ABC on our graph. We're going to state the coordinates of the preimage. So point A is located here at 5, 8. Point B is located right here, which is at 7, 3. And point C right here is at 2, 4. Those are the coordinates of the preimage triangle ABC. What they would like us to do in question B is reflect triangle ABC over the y-axis. So we're going to do a reflection this time. And we're reflecting over the y-axis, which is this vertical line right here. So what we're going to do is figure out where each of the points would lie with this reflection, and then we're going to call that triangle A prime, B prime, C prime, and state its coordinates. So let's first go with A prime, which is going to be the image of point A. We're going to take point A and reflect it over the y-axis, which means A prime has to be the same distance from the y-axis that point A is, just on the other side. If we count straight over to the left, A is 1, 2, 3, 4, 5 units to the right of the y-axis. So point A prime is going to have to be 5 units to the left of the y-axis. 1, 2, 3, 4, 5. That point right there is A prime, and its coordinates are at -5, 8. A prime is at -5, 8. Let's do the same thing with point B prime now. B prime has to be the same distance away from the y-axis that point B is. So here's point B. Let's count straight over. 1, 2, 3, 4, 5, 6. It's 7 units to the right of the y-axis. So B prime is going to be 7 units to the left. 1, 2, 3, 4, 5, 6, 7. Right there. That is point B prime. And its coordinates are -7, 3. -7, 3. Next, we're going to do the same thing with point C prime. All right, C prime is the same distance away from the y-axis that C is. So here's point C, 1, 2 units to the right of the y-axis. So now we're going to go 1, 2 units to the left. And that's where point C prime is located. And it's located at -2, 4. -2, 4. Let's go ahead and connect our 3 points here to create the triangle. A prime, B prime, C prime. All right, and one more line, and there we have it. And there is your triangle A prime, B prime, C prime. Okay, now letter C, we're going to reflect triangle A prime, B prime, C prime over the x-axis. So we're going to take this triangle now and reflect it over the x-axis. Label the coordinates as A double prime, B double prime, C double prime, and state the coordinates. So let's start with A double prime. Okay, this time we have to reflect it over the x-axis. So A prime, if we count down to the x-axis, that's 1, 2, 3, 4, 5, 6, 7, 8 units above. All right, A prime is 8 units above the y-axis, so A double prime is going to be 8 units below. Count that down here, and it's going to be this point right there. This is where point A double prime is located, and that's at the point -5, -8. -5, -8. Point B prime, B double prime rather. All right, well, let's reflect point B prime over the x-axis. Count straight down, 1, 2, 3 units. So now we're going to go 3 units below. 1, 2, 3 units below. That point right there is point B double prime, and it's located at -7, -3. -7, -3. Now we need C double prime, so let's take point C prime and reflect it over the x-axis. 1, 2, 3, 4 units above, 1, 2, 3, 4 units below. That point right there is point C double prime, and let's connect with our ruler. All right, there's our first, and now our second, and now our third line. And we get a nice triangle that looks like that right there. A double prime, B double prime, C double prime. And I forgot to state, say C double prime is at -2, -4. -2, -4. Very good. All right. Now, question D wants to know, is a reflection an example of a rigid motion? Well, remember that rigid motions create images that are congruent to the pre-image. So if you look at your triangles, here's our pre-image, ABC, and look at the two images, I would say that all three of these triangles are congruent to each other. So yes, a reflection is a rigid motion. All right, so we can say a reflection is a rigid motion, because the pre-image, which was triangle ABC, the pre-image is congruent to the images. All right, each image that resulted from the reflection created a congruent triangle to the pre-image. So yes, the reflection is a rigid motion. What do you notice about the coordinates when you reflect it over the y-axis? So let's go back up here. We took this triangle ABC and we reflected it over the y-axis and got this triangle A prime, B prime, C prime. Well, if you look closely at the coordinates, notice that the x-coordinates became the opposite. All right, 5 became -5, 7 became -7, 2 became -2, but the y-coordinates stayed exactly the same. That's always going to happen when you reflect over the y-axis. So what did you notice? Well, we noticed that the x-coordinates became the opposite. The x-coordinates became the opposite. But the y-coordinates are unchanged. The y-coordinates were unchanged. And then in letter F, what do you notice about the coordinates when you reflect it over the x-axis? So going back over here, we took this triangle, A prime, B prime, C prime, whose coordinates are here, and we reflected over the x-axis, which made this triangle, A double prime, B double prime, B double prime, C double prime, whose coordinates are right here. What do you notice about the coordinates? Well, this time, notice that the x-coordinates stay the same. All right, all the x-coordinates stayed the same, but the y-coordinates became the opposite. 8 became -8, 3 became -3, 4 became -4. When you reflect over the x-axis, then the x-coordinates are unchanged this time. The x-coordinates are unchanged, but the y-coordinates became the opposite. Okay, so that's a special fact that you can use whenever you're reflecting over the x-axis. And again, we're going to study these rules more in depth later in the topic. All right, but the important thing to recognize here is that a reflection is a rigid motion because it created congruent images to our pre-image. The last transformation that we'll look at in this introduction is the rotation. In 8th grade, rotations will always be centered at the origin and will always be in increments of 90 degrees. All right, so we're going to rotate images in increments of 90, 180 degrees, 270 degrees, and then if you rotate at 360 degrees, you actually get right back to where you started. Okay, also, The direction of a rotation will always be counterclockwise unless it's stated otherwise, okay? Counterclockwise moves you in this direction, opposite of how a clock moves. That's why it's called counterclockwise, all right? The diagrams below show counterclockwise rotations centered at the origin. So here was our original triangle. 90 degrees rotated counterclockwise gets me to this triangle. The original rotated 180 degrees counterclockwise gets you to this triangle. And the original triangle rotated 270 degrees gets you to this triangle right here. 360 obviously gets you right back to where you started. So counterclockwise is going to move in this direction, increments of 90, 180, 270 degrees. Okay? Clockwise rotations will move the shape in the opposite direction. Okay, so if this was my original triangle and I rotated it clockwise 90 degrees, that would get me to this triangle down here. A 90-degree rotation clockwise is the same as a 270-degree rotation counterclockwise. So again, if I start with this triangle and I rotate it 90 degrees clockwise, I get to this triangle. If I wanted to get to this triangle, but I move counterclockwise, I would move 90, 180, 270 degrees counterclockwise. And looking at the triangles in that example, is the rotation a rigid motion? Are all of the images of our pre-image triangle congruent to the pre-image? Well, looking at those, I would say yes, they are. A rotation is a rigid motion because the pre-image is congruent to the images. All right, rotating our original triangle created triangles that were congruent to the pre-image. Therefore, a rotation is a rigid motion. Okay, and just as a reminder, all right, clockwise moves you in this direction. All right, our rotations, though, are always going to be counterclockwise in this direction unless the question states otherwise. So hopefully after this little introduction, you have a good idea and are able to identify the different types of transformations we're going to work with in this topic.